Hello there. It's a comfort to share this quiet corner of the night with you. Outside, the world is hushed, and the great silence of space seems to lean in a little closer, holding all its secrets. Wherever you are, allow the edges of your day to soften and your mind to settle, like dust gently falling in a moonbeam. Tonight, we're going to whisper about the deepest structure of reality, a place where the fundamental particles we thought were tiny points dissolve into something much more melodic. We'll ask a tender question. What if the universe, at its core, isn't made of solid matter at all, but only of song? What if every electron, every atom, every distant star, and even the simple warmth of your own hand is just a different note played on an unimaginably small, vibrating string? This idea is both vast and profoundly simple, a lullaby whispered by the cosmos. It's a gentle exploration, and there's no rush to understand, only to wonder. If this quiet wandering brings you ease, a soft like and a quiet subscribe help others find their way to this calm, one gentle sleeper at a time. When you're ready, let the music begin. It didn't arrive as a banner in the sky or a promise to solve everything at once. It slipped in almost sideways in the late 1960 seconds, when rooms hazy with chalk were circling a stubborn question. If nature keeps a few faithful rulebooks, why won't they share the same table? Electromagnetism spoke clearly by then, and the nuclear forces had found ways to tell how the hearts of atoms hold together. Gravity, though quiet and royal, refused invitations. The pages would line up for a moment, then slide apart again. Somewhere in that era, a modest formula did something shy and startling. Read in a certain light, it seemed to describe not points with no size at all, but thin, one-dimensional threads. Not the kind you could knot around a box or set ringing with your fingers, but impossibly fine lines, far smaller than atoms, too quick and subtle for any instrument to betray. They did not sit still. They trembled with patterns so brief they would look like nothing. Hidden in those tremors lay the hint of a blueprint. In the older story, the universe is a tidy zoo: electrons, quarks, neutrinos, a list learned like constellations. In this whisper, often called string theory, those creatures are not separate beasts. They are notes on the same hidden string. Change the vibration, and the name changes with it. One mode hums as an electron, another shines as a photon, and another, more elusive, is the imagined graviton, the hypothetical particle of gravity that has evaded every net so far. Scale is where imagination gasps. If these threads exist, their length would be about 100 billion times smaller than the nucleus of an atom. No lens could help. No microscope, not even one dreamed by the boldest engineer, would catch a glint of such a strand. Yet the mathematics, intricate as frost on glass, has a place for them, and within that lattice appears a calm suggestion. Perhaps reality isn't brick on brick, but woven from motion. The word vibration can mislead. This isn't sound that rides on air or water. There is no stage for speakers here. The trembling is a pattern of energy itself, a choreography inside the fabric that underlies everything else. If reality has a soundtrack, it is written as equations and felt as consistency, a structure you can't hear but can follow by the way different parts agree. That alone would be a gift, a gentler room where the rules of the very small might share tea with the geometry of the cosmos. Quantum mechanics, with its quicksilver probabilities and sudden appearances, has long glared across the table at general relativity, Einstein's smooth description of space and time. Points make the quarrel worse. Push the math too hard and infinities bloom like weeds. Replace points with tiny strings and the trouble softens. The two great books stop shouting and, for a moment, settle into a shared rhythm. There is a price for this piece. The stage must be wider than the familiar 3 directions and the single line of time we count on our wrists. 10 dimensions, sometimes 11, depending on how the theory is tuned. Not extra rooms you could stroll through, but curled directions folded so tightly they hide in plain sight. Little hallways woven into every point, too small for even the smallest ray of light to slip along. If that picture is right, everything we see is only the surface of a more intricate loom. Not false, not lesser, just the visible face of something that stretches beyond our sense. The feeling it gives is not chaos. Think of a violin holding a steady note. The string is frantic, yet the tone steadies the room. The mathematics of tiny threads can feel like that wild beneath the eye, tranquil in what they imply. And still, honesty has its say. The idea remains unproven. No experiment has seen a string. No detector has nodded in recognition. To test it directly, we would need energies so high that even the Large Hadron Collider, the ring beneath the fields near Geneva, would seem like a toy set on the carpet. So the search goes the quiet way. Indirect clues in the algebra, small fingerprints in the behavior of the universe, hints that something like strings might be there. The debate that follows is lively and careful. Some worry that without crisp predictions, the vision will wander into philosophy, dressed in symbols. Others answer that much of physics began exactly that way, as disciplined dreaming that later built its own instruments. Part of why the idea lingers is that it touches something tender. Imagine the universe as a single instrument playing itself across rooms we cannot enter, across dimensions we cannot picture. It is audacious and strangely consoling. If it were true, then you and me and the bright points we call stars, and the planets that keep them company, and the atoms that stitch our rooms together would all be notes belonging to the same long song. Maybe the deeper question is whether we've been listening closely enough. The hour gets quiet, and a thought returns. Is there something under the surface we can't quite name? Daily life is counted by clean rhythms, lights switching, traffic patterns, calendars, but curiosity keeps a rhythm of its own. Some minds turn to beginnings and ask where everything came from. Others look ahead and wonder what happens when the lights go out. There is also a subtler question that stays behind when the room empties. What if the world is made of vibration? It has no easy answer. It may not have an answer we can reach soon. Still, when you look around, the idea doesn't feel foreign. Waves run everywhere. A song travels through a room and touches a glass until the glass trembles. A rail sings when a train passes, the note born from motion and shape. Even solids carry quiet dances among their atoms. Temperature is a measure of how much they move. Light itself can be drawn as a wave, a swift oscillation that travels across emptiness. The world is never truly still. It only appears calm because so much motion cancels into a graceful average. If everything holds its own frequency, then connection stops being a metaphor and becomes a mechanism. One vibration nudges another. Resonance gathers scattered motions into a shared rise. It answers a quiet hunger to belong to something larger, without surrendering what makes each voice particular. In a grand orchestra, the oboe is not the violin, the drum is not the flute, and yet the piece requires each of them. It is not sentimental to imagine physics that works the same way. Ancient imaginations felt this kinship long before equations learned to speak. In the East, A single syllable has been taken as a primordial seed, a sound said to cradle the beginning of all things. In the West, early thinkers pictured the heavens as an ordered harmony, each planet tracing a rhythm steady enough to be called music. Those were metaphors, but not careless ones. They guessed that what holds the world together might be described most honestly as a kind of order you can sense before you can prove. The metaphor tightens into a model. In the mathematics of strings, the basic pieces of nature may not be tiny pellets bouncing in a void, but threads that vibrate in precise figures. Each figure corresponds to what we've named a particle here, a force there. The electron becomes one pattern on the instrument, the photon another, and the graviton a shimmering possibility in the same family of motions. It is still a guess, but it is a disciplined one. It behaves, at least on paper, like a story that knows how to hold its own weight. A deeper curiosity trails behind. What would it mean for such vibrations to stop? Not just a note fading in a room, but a true halt, the world untroubled by any motion at all. The mind reaches for words like silence and nothing, but those are different doors. Silence is an arrangement. Nothing is an absence. If the cosmic instrument ever rested completely, would stars forget to shine? Would planets lose their paths? Would the book of us close? No one knows. The question leans toward philosophy with a scientific accent, and perhaps that is all right. Some doors are meant to open slowly. Without a direct experiment to press, the theory becomes a way to think. It invites us to stop dividing things into smaller and smaller crumbs, as if the answer lived in dust, and instead, to look for the shapes that ride above the crumbs, relations that stay true when details shift. Perhaps the clue has never been the parts, but the choreography, the way the parts lean on one another to keep a larger promise. This is where the strings keep their appeal. They don't merely redraw particles and forces, they redraw the arena. Space and time themselves might be woven from the same threads as matter, different figures in the same dance, not just the stage beneath the dancers. 10 or 11 dimensions might be folded at every point, not to confuse, but to complete, not to hide from sight, but to hold the pattern steady. All of this could still be wrong. The history of ideas winds through many beautiful groves before the path decides elsewhere. Yet, beauty is not a trivial guide. When physicists call a set of equations elegant, they mean that contradictions refuse to appear, that symmetries bloom, that pieces fit without being shoved into place. The feeling is like that held violin note, motion underneath, quiet coherence above. The skeptics keep the light honest. They ask for predictions that can risk being wrong, for numbers a laboratory can chase, for signatures a telescope can catch. They are right to ask. The reply for now is patience and craft, better mathematics, clever ways to squeeze new consequences from old assumptions, careful looks at the sky for traces so faint they hide in background static. No promises, only work. Meanwhile, the idea goes on living the way good questions do. It returns at odd hours. It sits beside us while we read about galaxies and feel very small and somehow complete. The same thread that hums an electron could, under another pattern, sketch gravity's gentle pull. The extra dimensions could be curled into every point, tiny hallways that keep the song in tune. What first seems extravagant begins to feel like a kind of thrift. One instrument, many voices. And if the world is built on patterns, then attention is not just curiosity, it is participation. We don't have to solve the equations to belong to the music. We are already in it, as surely as a single tone belongs to a chord. So maybe the real question was never only whether the universe is vibration, but whether we have learned to listen not with ears for sound, but with an ear for coherence, for the places where ideas settle like light. That question, once heard, doesn't rush to be answered. It stretches out and settles into something large enough to tilt the way we see the world. And that may be its quiet beauty. In a universe that never truly holds still, always trading one arrangement for another, the task might not be to capture a final answer at all, but to keep asking with patience, letting the question stay open, like a window at night. For centuries, our picture was faithful and sturdy. The universe as a collection of tiny, solid building blocks, atoms, then electrons and protons, and deeper still, quarks. That picture served us nobly. It gave us the language of chemistry and the craft of electronics, the confidence to send machines into the dark and read the faint light they return. And yet a good map is not the whole country. Beneath the surface, the trusted pieces might be waypoints rather than bedrock, signs that point towards something more fundamental. Here is where the new whisper begins. What we call particles could be the faces of one-dimensional strings, little loops or short segments that never stop moving. They have no thickness. They vibrate in exact patterns. The pattern matters more than the piece. One figure of motion appears as an electron, another as a photon, and yet another, if nature allows, as the graviton, the long-imagined quantum messenger of gravity. Even a particle's familiar properties, charge, mass, spin, could be the bookkeeping of how the string moves. It sounds intangible at first because we were trained to think in dots, small pellets with firm edges colliding like marbles. A trembling thread that can behave as many different particles asks for a softer imagination. The metaphor that helps is music. The instrument is one, the song is many. Change the mode and the note changes with it. The catalogue of particles becomes a list of resonances, and the strict numbers we measure become the grammar of an unseen rhythm. The promise, if it holds, reaches past the particles themselves. For more than 100 years, two masterpieces have sat across from each other like proud rivals. Quantum mechanics governs the small, uncertainty, superposition, sudden changes that look like magic until habit makes them ordinary. General relativity governs the large. Space-time bends. Gravity is geometry. Clocks run differently when the landscape curves. Each theory is luminous in its room, and each resists the other's rules. When they meet near black holes and at the first moments of the cosmos, their pages disagree. Strings soften those hard corners. A string has extension. It is not a point. That simple change blurs the sharpest edges, just enough to keep the mathematics from tearing. In the framework that follows, a quantum description of gravity emerges not as a patched-on extra, but as a natural voice in the same instrument, the graviton mode. The other forces, electromagnetism, and the strong and weak nuclear interactions come forward as different patterns on the same thread. Four voices that once sang in separate balconies learn to share a stage. There is a cost for this harmony. The equations balance most gracefully when space offers more directions than the three we travel with the one line of time. Many versions ask for 10 dimensions. Some invite 11. These are not extra corridors we could stroll. They would be curled so tightly that even light could not wander down them, folded like tiny hallways into every point of space. Their shapes would decide which notes the strings may play, and by choosing the notes, they would set the menu of particles and forces we can discover. Follow the mathematics a step farther. and a broader possibility appears. If those hidden dimensions can take on many shapes, and each shape supports a different set of allowed vibrations, then there may be more than one consistent world the instrument can perform. The equations suggest a landscape, perhaps a vast one, of possible tunings. In some corners of that landscape, gravity could be stronger or weaker, certain particles heavier or lighter, chemistry lively or barely possible. In others, the rules might nearly match our own, with only small differences that ripple outward into their histories. This is the multiverse some speak of. Not a boast, not a guarantee, but a consequence the mathematics seems willing to allow. Such talk is a candle rather than a streetlight, and yet it widens the frame of the question. We do not invoke the many to excuse our ignorance of the one. We keep the many in mind because the instrument we are studying seems capable of more than a single song. Whether or not nature uses that freedom, the thought changes how the room feels. It trades the image of a machine made of plates and bolts for a living score, a composition in which nearness and distance are steps in the same dance. The vocabulary changes with it. We speak less of substances and more of fields, less of pellets and more of excitations, less of collisions and more of resonance. The old language is not discarded. It is quoted inside a broader movement, still beautiful where it belongs. What once looked like pieces now reads like phrases, and phrases belong to a language that knows how to hold difference and unity at once. Testing such a language takes craft. We do not own instruments that can walk straight into the smallest rooms, so we study how the music leaks into the halls we can enter. We ask colliders to search for signatures of extra structure. We comb through the sky's fossil light for faint imprints that new degrees of freedom would leave. We test symmetry so strictly that any violation announces a deeper grammar. None of this guarantees a verdict soon, but it keeps the conversation honest. Meanwhile, a hum lingers at the edge of awareness, a sense hard to name that the world refuses absolute stillness. Sit with the night long enough, and something softer than sound shows through. It is not the whir of machines or the traffic over the hill. It is the reminder that motion is the background state, that even when a room seems quiet, the universe keeps time. In the smallest rooms of theory, that timekeeping is vibration. The music metaphor needs care. Vibrations here do not travel as ordinary sound. Sound asks for a medium air or water to carry pressure waves from place to place. The strings in this story move inside the underlying fabric itself, and their notes are conditions of energy that we experience as particles and forces. When a string hums in one figure, we label it an electron. In another, we meet light. In another, we would find the graviton if nature permits. Mass and charge become ways to index how the thread is allowed to move. And yet the metaphor helps us remember our place. Every day teaches that vibration ties the world together. A train passing 2 streets away makes a window sing. A bridge hums in a crosswind until engineers teach it a steadier rhythm. Even at rest, a solid object is busy. Heat is the name we give to the quiet exchange of tiny jostles among atoms. And light needing no air travels as a wave through emptiness, delivering color across the dark. Once you notice, the day is a layered pulse, and into that pulse, the deeper tremors of theory arrive as a kind of guidance rather than a noise. The thought is older than our equations. Long before the math, stories spoke of a primordial syllable, a seed sound from which the world unfolds, and philosophers pictured the heavens as a harmony with each wandering star keeping its measured pace. Those were metaphors, not mechanisms. But they tell us something durable. That order has a musical feel, whether or not it makes a noise. It is a gentle surprise when modern mathematics leans toward the same resemblance. The resemblance is not evidence. It is a reminder that ideas sometimes rhyme across centuries. Perhaps the real gift is the way the question loosens the grip of certainty. The claim that the universe might be woven from vibration is unlikely to yield to a single proof soon. It may sit at the edge of what we can measure for a long time, shaping the way we look even before it can be closed. Meanwhile, the view it offers is generous. Instead of a pile of separate things, we are invited to consider a connected whole. Instead of a static background, we are offered a fabric that participates. Instead of separate stories, we are given a single narrative written in many keys. Caution has its place beside wonder. Without predictions that can risk being wrong, theory grows soft. Without humility, elegance can seduce us into keeping a pretty explanation that does not belong to the world. So the work proceeds in two keys at once: tenderness for a vision that holds much together, and rigor toward any claim it makes. Perhaps that is why string theory keeps its audience even when evidence stays shy. It offers a way to talk about unity without erasing difference, a way to imagine how the very small and the very large can keep time together. Stand back from the blackboard, and the picture softens into something almost comforting. If everything is vibration at its root, then everything is relation. A pluck here implies a response there. A field leaning in one place asks another to lean back. Even what we call empty space is restless, full of possibilities waiting to be coaxed into form. The cosmos becomes less a warehouse and more a conversation. There is no promise in this, only hospitality. We don't have to be sure to be invited. The score is already playing, whether or not we know how to read it. Planets keep their time, atoms keep theirs. Between them, the page carries patterns we're only beginning to notice. If the universe is truly written in vibrations, then you and I, and the air that cools the night, are not bystanders. We're part of the phrasing, brief notes in a much longer line. That recognition doesn't settle the question. It simply makes room for wonder without demanding certainty. So the window stays open. The world keeps changing while we listen. Strings remain a proposal, disciplined, imaginative, tested in pieces, and by implication, and the multiverse stays an option the equations allow, not a guarantee. Extra dimensions may be folded into every point, quiet as hidden hallways, setting the tuning for all that follows. And the old particle picture, which carried us so far, isn't thrown away but held inside this one, like a good melody, quoted in a new movement. The thought is radical and tender at once, and the night is wide enough to hold it. Inside that wide night, vibration doesn't stop at the boundary of the tiny. It reaches into the stage itself, so that space and time are not rigid boards laid beneath the play, but living parts of it, pliant, responsive, capable of their own quiet motion. Space-time can stretch and pucker and ripple the way a string does, and the figures it draws are not just decorations wrapped around matter. They help decide what matter is allowed to be. What the strings sing, the stage answers. What the stage permits, the strings can sing. That is why the idea of hidden directions matters. If vibration sits at the heart of things, then the heart must have more room than the three we use to point left and right, forward and back, up and down, and the single, patient river we call time. The mathematics that keeps the story honest suggests additional directions folded away so tightly they hide in plain sight. These are not aisles you could walk. They are tiny hallways stitched into every point, shaping which notes the instrument can hold. The familiar world becomes a kind of surface of a deeper weave, and the extra folds inside each point behave like small tuning chambers, changing the color of every note that passes through them. Seen this way, solidity loosens into pattern. The chair, the stone, the orbiting planet they wear, the look of rest, but underneath is a constant tremble. Strings vibrate, the fabric vibrates, and from their interplay, the architecture we experience is born. One figure of motion becomes an electron, another becomes light. Another, more elusive, would be gravity's own quantum, arising not from an added law, but from the instrument's repertoire. When people speak of unification, this is the tone they mean. Not one thing smothering others, but one instrument, capable of many voices, each voice a lawful mode of the same motion. The same tone reaches toward a long-standing quarrel. On one side, quantum mechanics governs the quicksilver behavior of the small. On the other, general relativity tells how mass and energy bend the room itself. Try to force them into the same paragraph and infinities climb the margins. Replacing points with small strands softens those rough edges. Even gravity steps into the same rhythm, its carrier appearing as a particular allowed vibration. The equations stop shouting. For a span of lines, they sing in key. Because the instrument is subtle, so are the ways we might test it. Strings would be far beyond the reach of any microscope we can dream, and the extra directions, if they exist, would be curled smaller than small, yet consequences seep outward. The shapes of the hidden halls can influence the masses and charges of familiar particles. They can tune the strength of forces. They can nudge how early light cooled and spread. Even gravity's peculiar gentleness may find a story here. If other forces are mostly confined to the broad surface we live on, while gravity is free to wander the tucked dimensions as well, its pull would be diluted when measured on our surface, still universal, still essential, but softer to the hand. Weakness would not mean frailty. It would mean that gravity has more room to roam. Inside that possibility sits another, that the constants we recite with such trust are not etched in stone, but arise from how the hidden rooms are folded. Different foldings, different menus of allowed vibrations. From one shape of the tiny hallways, a universe with our familiar chemistry. From another, a world where the same instrument performs a different score. The thought is sometimes called a multiverse, not as a boast, but as a description of how many stable tunings the mathematics seems willing to host. Whether nature chooses one or many, the hint changes the lighting. Fine-tuning stops looking like a miracle and begins to look like a choice of key. If this is the right kind of picture, forces themselves are variations on the same theme. The strong and the weak nuclear interactions, electromagnetism, and gravity, four voices that used to feel unrelated could be different phrases of one syntax. A photon would be one clean mode of the string, a gluon another, the graviton a shimmering cousin in the same family of motions. What seems separate at our scale becomes connected lower down, the way distant branches share a trunk underground. Questions, of course, multiply. What is it that vibrates, if not a substance set inside space? The answer the theory offers is a gentle one. The vibration is of the fabric itself. In daily life, a wave needs a medium air to carry sound, water to carry a ripple. In this story, the medium and the motion live together. There is no need for a prior stage. The stage is drawn as the play unfolds. The note and the room that holds it are two views of one object. Because the note is quiet, we learn to listen by indirection. We check the way particles scatter and compare the numbers across distant laboratories. We sift the sky's relic light for faintly printed signatures of extra features in the early choreography. We push on gravity at very short distances, asking whether its pull deviates from the curve we expect. Each test is humble and hard. Together they keep the idea honest enough to remain in the conversation without pretending to be finished. Hidden directions ask for words that don't force the mind into corners. The image that helps is this. At every location, there could be tiny rooms folded into the point. Rooms with shapes too small to visit, but influential enough to set the instrument's tuning. The rooms are not elsewhere. They are here, layered beneath the familiar length, width, and height. The way grain lives inside wood. We see the surface. The surface carries clues about what is inside. And the counting matters. Many versions of the mathematics find consistency most naturally when there are 10 dimensions in all 9 of space and 1 of time, with another formulation leaning toward 11. The extra directions are not extravagance. They are structure, required so that the allowed vibrations behave and the contradictions that plague cruder pictures do not appear. If the numbers feel extravagant, remember that their job is not to be seen, but to keep the rhythm steady. The notion that gravity is weaker than the other forces stops being a curiosity and becomes a feature of this architecture. Light and the nuclear interactions may be tied tightly to the broad sheet we inhabit, while gravity, in this suggestion, has a foot on the sheet and a foot in the folded holes. Spread a message across more rooms, and any one room hears it more softly. Yet gravity carries the shape of the whole, which is why it rules the vast even if it seems shy in the small. Old questions look different under this light. What we name a particle could be a brief phrase sung by a loop. What we name a field could be the way a family of such loops share timing across space. What we call empty space could be crowded with possibility. It's quiet, full of allowed motions that flicker into and out of being. The world we touch does not become less real for being woven. It becomes more intelligible. The way a tapestry makes sense when you notice the pattern that keeps returning. Proof remains ahead, and the path bends. We do not claim the strings have been seen, or the extra rooms measured, or the full score played. What keeps the idea alive is the way it pulls distant facts into a single key and offers tests that, though subtle, are real. It also changes how the room feels. Instead of a warehouse of separate pieces, there is a single instrument whose modes interfere and reinforce, making the world we know. Instead of a rigid background, there is a fabric that participates. Instead of answers that close every door, there are questions that open windows. Everyday experience does not contradict this. It hints at it. A bridge hums in a crosswind. A glass sings when a note finds it. What looks still reveals a shimmer when the light is right. Those are small rehearsals for a broader idea. That relation is more fundamental than thing. That rhythm is more basic than rest. The lesson is not mystical, it is practical. Patterns persist, details change, and it is the persistent patterns that explain why details can change without breaking the whole. If there are many stable shapes for the hidden rooms, most will remain forever beyond our walk. That need not frustrate. We can still ask which shapes would make a world like ours, with its light elements and long-lived stars, its chemistry generous enough to build rivers and rocks and mines. We can ask what slight deviations would do, how a small twist in the folded holes would shift a particle's mass or tilt a force. We can ask whether some subtle asymmetry left a print in the sky we already photograph. Each question ties the unseen to the seen by a length of careful thread. In quiet moments, the thought turns simple again. Maybe reality isn't a pile of separate objects at all, but a web of resonances. The solid feel of things could be the way our scale translates a faster song. The constants we treasure might be the key and tempo chosen by the small, hidden rooms. None of this asks for belief. It asks for attention. The music is not something to hear with ears, but to notice in the coherence of what keeps working the way. Ideas, born from different directions, still meet on the same note. A theory doesn't have to be finished to be useful. It needs to guide, to suggest, to avoid needless complication, to make peace between rivals without cheating either. In that sense, this instrument has already given much. A way to see particles and forces as related, a way to imagine why gravity wears its gentleness, a reason to consider extra rooms folded into every point. From there, the counting returns like a quiet refrain. There is a certain number of directions in which the music can stay consistent, and the numbers don't insist on themselves so much as on harmony. Harmony, even when you cannot hear it directly, is a kind of proof the mind can rest inside for a while. Gravity turned out to be the missing piece that sharpened that counting. At first, the equations behaved most politely, with 10 total dimensions, 9 of space, and 1 of time, like a puzzle that almost closes, but leaves a hairline gap. When gravity's full voice was invited in, the picture asked for one more subtle direction, not spread wide like the others, but present all the same. 11 became the number that calmed the book, the extra page that lets the binding lie flat, so that the score can be read without strain and the underlying harmony holds. Why, if such directions exist, do they escape the eye? Because they are folded so tightly that even light, which threads needles for a living, finds no corridor to travel. The word that helps is compactified, tucked into loops so small, the turns are hidden inside every point. Imagine the tiniest crease in a paper that otherwise looks smooth, or secret pages bound into a spine that reveal themselves only when the binding is flexed just so. The extra rooms are there by design, woven into the points we take for granted, shaping possibility while remaining out of view. Even though we cannot enter them, the hidden rooms still reach us. They decide which vibrations are allowed to settle, and by deciding that, they choose the menu of particles and forces that give our world its regularities. Gravity's particular gentleness is one of the places their influence may be felt. If the other forces live mostly on the broad three-dimensional surface we inhabit, while gravity can wander the tucked directions as well, its pull looks diluted when measured on our familiar slice. Weakness, in that light, is simply the sign of a wider reach. Once you admit extra rooms, a further possibility follows as calmly as a thought. There might be many consistent ways to fold them, each fold choosing a different set of allowed notes. In one fold, certain particles are light and certain reactions brisk. In another, the mix is different. That is the multiverse. Many speak of not a parade of cartoon worlds, but a landscape of viable tunings the mathematics does not forbid. We do not know which fold nature chose, only that our own is one in which stars live long and chemistry has patience. It is humbling to consider that what we touch may be only the surface of a deeper weave. The strings that sing the electron or the photon draw their figures not in empty space, but across a fabric that participates. The fabric's own tremors help choose the key. The picture grows richer without growing louder. One instrument, many modes, one page, many scripts written in the same ink. The unfinishedness of the picture is part of its honesty. 11 directions may calm the algebra, but we have not walked the extra halls or photographed their corners. The framework remains a work in progress, like a piece of music whose lines are elegant and persuasive, but missing a definitive cadence. The silence in those missing bars is not failure, it is room for discovery. We test what we can, the slow way, by inference and patience. Some tests seek the hidden rooms themselves. If they are real, they should leave tiny fingerprints on the behavior of particles at high energies, or on the exact way gravity bends at short distances. A collider might, in principle, nudge matter hard enough to hint at new pathways. Telescopes might read the early sky for subtleties in the background light left from when the universe was young, small deviations that whisper about extra structure in the fabric. None of these are easy. They are instruments asking to hear a very soft note in a room full of ordinary sound. Other tests look to gravity's extremes. Black holes are laboratories written in night, places where quantum rules and curved space-time share a room. If strings are real, their mathematics suggests that the entropy of a black hole, the way its hidden microstates count, can be understood as a tidy ledger of stringy configurations. The details are technical, but the moral is gentle. The theory offers ways to calculate things that once seemed untouchable, and those ways agree with quite different lines of reasoning. Even the idea that information is not truly lost in a black hole finds a language here, one that treats the boundary and the interior as two faces of the same book. The multiverse itself is the most elusive to weigh. If other consistent tunings truly exist, they may lie forever outside our horizon. Still, their shadow can be felt in how we think about why these numbers. What used to sound like a miracle constants just right for long-lived stars and fertile chemistry begins to sound like selection. We are in a region where the key supports a long song because only in such a region could listeners appear. That logic does not settle the matter. It simply makes the question gentler to hold. For all its unproven status, the framework keeps teaching. Its mathematics has given new tools to people who study geometry and quantum fields. Ideas that began as scaffolding for strings have found use elsewhere, crossing into problems that did not ask for strings at all, and yet benefit from their language. This kind of cross-pollination does not crown a theory. It does show that the garden it grows in is healthy. Even within the string picture, the cast turned out to be broader than a single kind of strand. Some strings are open, with loose ends. Some are closed, forming tiny rings. The rings move like minuscule rubber bands, able to slip through places their open cousins cannot. Closed loops are natural carriers for the sort of vibration we identify with gravity, which fits our earlier intuition that gravity roams wider than the other forces. Open strings need places to end, and those places, their anchors, are themselves physical. They are called brains, from membranes, and they can have more than one dimension, from lines to sheets to volumes and beyond. If you picture a brain as a vast, gently flexing sheet, then an open string with both ends attached to it can only move along the sheet. That motion becomes the familiar matter and forces we measure. A closed loop, free to pass through the sheet, can drift into the larger depth. Gravity, in this story, is the drifter. Our everyday world could live on one such brain, a warm raft in a higher dimensional sea. Most of what we call physics is the weather on the raft. The sea explains why gravity's tide feels soft. It spreads across more water than we can see. Brains can carry their own vibrations, just as strings do. The sheet can ripple. Those ripples act like particles from the raft dweller's point of view. Two brains can pass close and interact. Energy can gather where they meet, changing the local menu of allowed notes. In some imaginations, the beginning of a cosmos is not a flash from nothing, but a moment when brains brushed, energy bloomed, and a new patch of fabric began to cool and write its story. These are pictures painted with careful mathematics and a willingness to follow its implications wherever they lead. The number 11 returns here with a quiet authority. When people tried to harmonize the different versions of string theory, each a perspective on the same instrument, they found that an even larger view, often called M theory, steadied the frame. In that view, strings share the stage with brains of various dimensions, and the full harmony prefers 11. You do not need the details to feel the intention, to gather many tunes into one score without forcing any to sing out of range. What makes this menagerie more than daydream is how naturally it can reproduce known music. Electromagnetism, the strong and weak nuclear forces, gravity's curve, the quicksilver habits of the quantum within the framework, they appear as consistent phrases rather than patched rules. That unity is the quiet promise that keeps people at their chalkboards and keyboards, working through nights that lengthen around them. When a line of math lines up with a line of observation, the room gains a little more light. Even so, the theory does not insist on belief. It asks only for the kind of attention we give to a good draft. Are its assumptions clean? Are its consequences specific? Does it risk being wrong in ways the world can, in time, check? The answers are slowly collected. A new symmetry is proposed. Someone else asks whether it would forbid a decay we have already seen. The proposer adjusts. The skeptic refines their doubt. The experimenter tweaks an apparatus to listen a little more carefully in a narrow band. The rhythm is incremental and patient. Beneath the technicalities, the human feeling is simple. It is the sense that order might live deeper than the parts we can hold, and that the parts we can hold are faithful shadows of a more generous pattern. In a vision like this, nothing stands entirely alone. A change here implies a response there. What we call constants are the way the pattern keeps its key. What we call particles are notes that ring in that key. What we call forces are rules for how notes lean on one another to make a phrase. Even space-time is not a mute backdrop, but a participant with its own quiet voice. It is right to remember that the choir may be larger than we will ever hear in full. There may be folds we never unfold, brains we never brush, rooms we never enter. The usefulness of the song does not depend on finishing every bar. Each time the framework recovers a known result in a new way, each time it suggests a calculation that fits the world, each time it turns a tangle into symmetry, our confidence grows by a small, earned measure. So the thought continues, steady and unhurried. Extra directions exist here not as fantasy, but as a disciplined answer to a precise demand for consistency. Their compact folds can hide from our eyes and still shape what is possible. Gravity's whisper may be the sound of its wider reach. Closed loops and open strands can share a stage with the brains that host them. And the number 11 can be less a flourish than a quiet truth about how many directions the instrument needs to keep the music from tearing. Some of the most suggestive shapes in this picture are the brains, broad, flexible stages where strings can fasten their ends. They are not limited to the three spacious directions we know. Brains can extend across the hidden folds as well, inhabiting the extra dimensions the mathematics keeps asking for. In some tellings, everything familiar, light, matter, the quiver of the quantum fields that make up our weather of reality could be confined to such a brain, while the larger, higher dimensional room that holds the brain remains largely unseen. What feels like empty space might be only the thin interior of a wider structure, a surface within a volume we rarely sense directly. If that is the case, then the forces we meet every day can be local to the sheet. Photons, electrons, quarks, modes of open strings whose ends are tethered, would travel along the brain like notes written on parchment. Gravity, born by closed loops with no ends to tie down, could slip off the page and wander the wider depth. That small freedom softens gravity's hand on our brain, the way a voice spreads and becomes faint when it echoes through many chambers at once. The gentleness we measure would not be weakness, but the sign of a wider reach. Brains are not just stages. They carry their own energy and can ripple. A heavy brain stretched across hidden directions might undulate, and those undulations would send ripples into the surrounding fabric, subtle waves of curvature that run like rings on a pond when stones touch water. Where brains approach or brush, energy can gather. Excitations can arise on their surfaces. Patterns can begin that, translated into our language, read as particles and forces. It is a mind-quieting image. Structure not as a pile of parts, but as a choreography among surfaces and threads. If one brain can float in the larger room, another can as well. Nothing in the equations forbids multiple brains, each with its own weather, each hosting its own cast of strings and laws. Some could be close, others unimaginably far in the higher dimensional sense. Most would never meet. Put this together with the many ways those hidden holes can be folded, and a wide landscape appears. Many possible worlds, many possible tunings. The thought offers a gentle explanation for why our constants look just so in our corner. We live where the key supports long-lived stars, generous chemistry, patient time. Ideas like these invite both wonder and restraint. Much remains unknown. The algebra is precise, but technical. The evidence is indirect and scarce. Brains in loops are predictions written at scales beyond any microscope we can build today. We reach for them slantwise, asking what clues they might leave that a careful ear could catch. The search is not a sprint. It is the kind of listening that rewards steadiness. A small departure in how gravity behaves at short distances, a particular signature in the sky's oldest light, or a telltale pattern in the tremor of space-time when massive objects collide. Under all of this lies the older, stranger ground called quantum mechanics. Down there, certainty thins out. A particle is not a bead with a pinpoint position, but a cloud of possibility, a wave of potential outcomes that sharpens only when we look. The same entity can reveal itself as a wave in one arrangement, a particle in another, as if nature were bilingual and we are the ones who choose the dialect by the questions we ask. This wave-particle duality does not make reality fickle. It makes our old categories too stiff for what is actually happening. String theory inherits that dance and deepens it. A string is never truly still. It occupies many allowed shapes at once until a specific interaction asks it to choose, and even that choosing is ruled by probabilities that add like overlapping notes. The electron we mention so casually is, in this view, a pattern of vibration on a string living on our brain. Light is a different pattern, often traveling at the edge of what the brain can carry. Gravity's messenger is the closed loop that slips through the larger room and returns. The world becomes less a warehouse of things and more a score of relations. Even the stage learns to move. In general relativity, Einstein taught us to trade the picture of a force tugging at a distance for the picture of geometry, mass and energy, curve, space-time, and objects follow the curves. The theory is powerful and exacting for planets, stars, and the great lenses that bend light around galaxies. But its equations are classical. They do not speak the probabilistic language of the quantum, where the smallest rooms matter near the beginning of the universe. Near the hearts of black holes, the two voices need a shared grammar. Strings and brains offer a common idiom. Curvature becomes a mode of excitation. The force of gravity becomes an exchange of closed-string quanta we call gravitons, ripples that are as lawful and quantum as the photons that carry light. Space and time themselves become responsive. They are not rigid scaffolds, but participants that can quiver, stretch, even tangle a little in the quantum way before smoothing out at larger scales. The picture is not noise. It is music that averages to quiet when you step back. Another feature of the quantum that keeps surprising us is entanglement. Two parts of a system can become linked so that their states are not independent, no matter how far apart the parts later drift. Measure one carefully, and the other's possibilities snap into place to match, as if a hidden rhythm had kept time between them. It feels like communication, but it is not a message. Nothing useful outruns light. It is a deeper kind of order, one that says the whole can be more definite than any of its pieces. In the language of strings, entanglement becomes a natural way to talk about how vibrations share information across a brain, and how closed loops that roam the bulk can correlate distant places without breaking relativity's speed limit. None of this cures the strangeness. It teaches us how to sit with it. Time itself can blur in the small rooms. A system can evolve along many nearly overlapping tracks until an interaction singles out one. To us, accustomed to clocks with steady hands, this looks like indecision. To the mathematics, it is a faithful accounting, the world allowing all it can until a particular exchange requires a definite tally. The effect is not mystical. It is subtle bookkeeping that becomes ordinary once you learn the tune. Through this lens, gravity becomes less a pull than a resonance, a standing wave of the fabric itself that closed loops carry and brains respond to. We already know what its large-scale version looks like. Space-time curves. Planets follow geodesics. Light arcs around a mass and arrives a fraction late. The new piece is the small-scale voice, the graviton mode among the strings, the way a ripple travels even when no air exists to ferry sound, the way a disturbance in geometry can be quantized like any other field. As always, the test is the teacher. We look for whispers a strong theory cannot help but leave. Do high-energy collisions produce missing momentum that hints at motion into the curled directions? Do gravitational waves carry fingerprints of extra structure when two black holes merge? Does the cosmic microwave background, the afterglow of the hot beginning, hide small asymmetries that a brain's early ripples would explain? Each idea asks a particular ear to listen, and as our instruments grow steadier, the listening improves. Meanwhile, the language of brains keeps showing its utility. Open strings that end on a brain describe the familiar forces that make atoms hold and stars burn. Closed strings describe gravity's roaming tendencies. The brain itself can vibrate in slow, broad modes that look to us like new fields. Two brains passing close can trade closed string loops the way two people exchange a quiet glance. The exchange changes the tension on each and adjusts which notes are easy to play. In some careful models, Even the early heat of the cosmos can be pictured as energy left behind when brains brushed in the higher room. The quantum world that underwrites all this remains as counterintuitive as ever, but the metaphors grow kinder. Instead of billiard balls on a table, think of a choir holding a chord. Any one voice is real and local, yet the chord's character comes from relations among all the voices. Shift the pitch of one singer, and the whole chord changes. Silence one, and a new harmony emerges. Strings and brains give that image physics. What we call particles are sustained notes. What we call forces are rules for how notes lean on and answer one another. What we call space-time is the hall that also hums along. Skepticism has its rightful chair in this room. Without measurements, a beautiful picture is still a picture. The scale of the strings is likely near the Planck length, a reach so small that even our great collider would need to be unimaginably stronger to touch it directly. But beauty is not the only reason the work goes on. The framework keeps paying rent in calculations that match known results from unexpected angles, in cures for infinities that used to swell and ruin the page, in new correspondences that let problems in one corner borrow solutions from another. Even where strings may not be the final word, the language they brought has proved durable. If brain worlds are a fair description, our daily lives unfold on a warm raft. Most of the weather we feel light. Chemistry, the push and pull in atoms, belongs to the raft itself. Gravity is the tide that rises from the deeper sea and returns to it. Distant rafts may drift elsewhere on the same ocean, lit by stars we cannot see, ruled by tunings we cannot guess. Nothing in this image diminishes our place. It integrates it, making our smallness part of a larger coherence that holds. The closer you listen, the more the metaphors simplify. A ripple is a ripple, whether you call it a photon on a brain or a graviton in the bulk. A pattern is a pattern, whether it belongs to a field in a lab or to the early sky. The lesson keeps repeating: relation first, pieces second. And under that lesson runs a quiet promise that the unfinished score we keep hearing will, in time, reveal more of its steps. For now, the music is enough to keep us company. Strings trembling, brains breathing, closed loops, traveling the wide room and returning with news we are just learning how to read. Gravity keeps a different kind of diary than the other forces. Electromagnetism crackles and holds atoms together with confident strength. The nuclear interactions work deep inside the heart of matter with an urgency that brokers no debate. Gravity, by comparison, feels like a whisper. A dropped key finds the floor. A planet traces its patient oval. A galaxy gathers stars with a pull that is firm but strangely faint. Why should the oldest shaper of the cosmos be so gentle at our scale? Within the string-based picture, the answer turns toward the hidden rooms. If space has more directions than the 3 we walk, and the one we count as time 10 in some tellings, 11 in the broader score, then not every force need be confined to our familiar sheet. Photons and the nuclear players seem tied to the brain that hosts our daily physics, their notes written along the parchment of our world. Gravity, carried by closed loops with no ends to pin down, can wander. It spreads into the compact, folded corridors, as well as across the sheet we inhabit. Measured only on the sheet, its pull looks diluted, the way a voice thins when it echoes through many chambers at once. Weak here does not mean weak everywhere. It means wide. That breadth hides a quieter strength. Near the edges, where conditions run hot and tight, just outside a black hole's horizon, or back near the first bright instance, gravity speaks up. The same closed-loop vibration that seems modest in ordinary rooms becomes the dominant rhythm when energies crowd and distances shrink. Strings do not merely live inside space-time. Their collective motion helps weave it. Curvature is not an afterthought, but a native tone of the instrument. And the graviton, a particular pattern among the closed loops, is the quanta of that tone. Gravity is no longer just a pull from a distance. It is a resonance of the fabric itself, a pattern that carries information about where mass and energy reside, and how the room must curve in reply. This shift of view opens a path toward an old reconciliation. Quantum mechanics governs the small with statistical grace. General relativity governs the large with geometric calm. Where the two overlap, they quarrel unless the underlying things are not points but trembling strands. Replace points with strings, and many of the infinities that used to boil up are soothed. Gravity steps onto the quantum stage as a fellow performer, not a visiting dignitary. A theory of quantum gravity stops being a slogan and starts being a craft. Quantized ripples of geometry, exchanging energy like any other field. Proof, for now, keeps its distance. No one has caught a graviton in a net, and our instruments cannot yet walk the curled directions that might explain gravity's gentleness. Even so, the picture offers a disciplined hunch that ties together places where our older maps blur. Black holes, for instance, look different under this light. They are not merely traps, ending in a nameless point. They are laboratories, where strings and brains are stretched to their limits, and the horizon behaves like a peculiar surface with temperature and entropy. Information long feared lost may be written in the vibrations that live on or near that surface, encoded not as ink on paper, but as patterns on the edge of space itself. The paradox softens. What falls in is not erased. It is archived in a language we are learning to read. The cosmos recently handed us a new way to listen. When heavy objects collide, the fabric ripples. Gravitational waves run outward, thinning as they go, but keeping the shape of the event that made them. Detectors on Earth have heard those ripples, the soft thud of distant mergers arriving as changes smaller than a fraction of a proton's width. If black holes have more to them than classical geometry, if strings and brains leave a signature in how horizons ring down, then the waves are a kind of microphone pressed to the skin of space-time. Careful listening may eventually tell us whether extra structure hums beneath the classical note overtones too subtle for earlier instruments to catch. Speculation goes further, with all the caution that word deserves. Some sketches suggest that the end of a black hole's long evaporation might seed something new, a pocket region whose own expansion begins. Sealed off from ours, a soft thought about Genesis as an echo, rather than a single shout. Evidence is absent and may remain so, but even the possibility revises how we hold the word end. The universe, in this telling, is a composer that reuses themes in unexpected keys. Entanglement, meanwhile, quietly threads through every page. Two quanta prepared together can drift to opposite edges of a galaxy and still behave as parts of one description. Measure one, ask it a sharp question about its spin or polarization, and the other's answer is fixed in the same moment, not because a message raced between them, but because the pair was never truly two separate stories. Einstein called the effect spooky. Experiments have given it the most ordinary award of all, repeatability. It happens every time the conditions say it should. In a string-woven world, the spookiness loses some of its chill. What looks like two distant particles could be two touches on the same underlying thread, or two notes that share the same bar line on a hidden staff. Distance is a rule for rulers. Entanglement is a rule for relations. The weakness of gravity at our scale fits this relational view. If most of the familiar forces are pinned to our brain while gravity ranges through the compact directions as well, then a simple field strength measured here is the wrong metric for its real scope. Spread across extra rooms, the same influence feels faint in any one of them. Paradoxically, that faintness grants reach. Gravity dominates the architecture of the large because it cannot be screened or trapped, because it answers to mass and energy wherever they live, because it keeps accounts across every hole the instrument contains. What seems like a quiet voice becomes the conductor's steady hand. The earliest moments of the cosmos are another place where a string-based gravity could explain a stubborn grace. Why the initial fireball expanded so evenly. Why the tiny wrinkles that later grew into galaxies have just the right statistical flavor. Why the background light that fills the sky looks almost, but not perfectly. Smooth all of these questions. Invite answers that mix geometry with quantum noise. Strings and brains offer mechanisms for such mixtures, allowing small, lawful jitters of the early fields to be stretched across the sky and frozen into a map we can still read. None of this makes the work less hard. Gravitons keep to scales that mock our reach. Extra dimensions hide like careful origami. Even the best detectors spend most days listening to quiet. Yet progress has a way of sneaking up when patience is kept. Techniques devised for these questions have fed back into mathematics, condensed matter physics, and the study of quantum information, where entanglement is treated not as mystery but as a resource. Theories talk to one another more than they used to. When a calculation agrees from two distant directions, geometry here, statistics there, the room brightens a shade, as if the same theme had been found in a different instrument. The old narrative of gravity as a force alone slowly gives way to a layered story. On sidewalks and in orbits, Newton's shorthand is perfect music. On cosmic scales and in strong fields, Einstein's geometry sings with deeper harmony. Under both, the string-based resonance keeps time, whispering that space-time itself is a participant, that curvature can be counted like other quanta, that information survives even when we thought it had no place to go. The layers do not compete, they cooperate, each recovering the others when the lights are turned down or up. Questions remain larger than answers. Could we ever build an instrument fine enough to glimpse a deviation in gravity at sub-millimeter distances that would hint at an extra fold? Could high-energy collisions reveal missing momentum that suggests motion into hidden halls? Could the spectrum of a black hole's ring down show a tiny, telltale splitting of tones? The list reads like a set of riddles left on a table at night, the kind you turn over in your hands because the shape is pleasing even before the solution arrives. Until solutions come, the picture we can hold is this: gravity is not an interloper, but a native rhythm, spread across more rooms than we can enter. It feels soft nearby because it is generous elsewhere. It ties galaxies together with patience, steers light with grace, and, in the smallest rooms, speaks the quantum language with the same fluency as the other forces. Black holes are not holes, but instruments. Their horizons capable of ringing. Gravitational waves are not metaphors, but messages. Entanglement is not superstition, but bookkeeping, for a world that values relations over pieces. When the pull of the earth reminds you where down is, it is tempting to call the story finished. A weight, a fall, an ordinary fact. Let the thought linger a moment longer, and the same act becomes a chapter in a longer book. A closed loop humming through folded corridors. A brain holding the familiar weather of matter. extra dimensions lending their quiet dilution, a geometry that curves just enough to guide a leaf to the ground, a register that keeps information even when darkness tries to hide it. The melody is not loud, and it does not demand belief. It invites listening, which is the first step toward understanding, and sometimes the only one available when the night is vast. Somewhere far from here, two black holes are circling, their orbits decaying grain by grain as waves carry energy away. Somewhere closer, a pair of photons born together depart in opposite directions and yet remain part of one description until a measurement asks them to speak. Somewhere between those scales, you and I live on a warm brain, feeling a gentle pull as the earth answers the mass we carry. The same instrument plays all three scenes. If strings and brains describe that instrument correctly, gravity's secret voice is not merely a background hum. It is a melody that keeps time for everything else, a patient line we are only beginning to hear with clarity. Non-locality sounds like mischief until you sit with it long enough to hear its logic. In entanglement, what happens here can shape what happens there, without any courier slipping between the two. No signal travels, no rule of light is broken. It is simply that the pair was prepared as one story, and the world insists on finishing the sentence in a way both halves agree upon. Space keeps its distances for rulers and maps. Relation keeps its nearness for the state as a whole. If the basic ingredients are vibrating strings that can lean across hidden directions, then such connectedness stops looking like a trick. It becomes an ordinary feature of a universe, stitched more tightly than it appears. Some have suggested that this stitching is not decoration but structure, that the geometry we walk through could be woven from the same threads of correlation we call entanglement. Picture a tapestry with no fabric behind it, only the interlacing itself. Pull threads apart, and the pattern thins. Knot them more closely, and the pattern thickens into what we would call space. In that view, distance is a measure of how much entanglement wanes. Curvature tells how those links are arranged. The dimension of the room is the richness of the weave. It is a daring proposal, not space-time producing quantum ties, but quantum ties producing space-time. If strings tremble together in enough coordinated ways, a shape emerges, a stage conjured by the very chorus that performs upon it. Follow the idea a step further, and a bolder whisper arrives. Perhaps some entangled partners are joined by minute tunnels in the geometry, not highways for messages, but bookkeeping bridges the fabric throws in to keep accounts balanced. Two particles prepared, as one could be thought of as two mouths of a microscopic passage no traveler can use. The passage is not there to move anything faster than light. It is there so that the whole remains a single story, no matter how far its pages drift. If such bridges lace the cosmos, the universe is richer than the emptiness we imagine, a quiet mesh of hidden connections, binding regions that look separate to the eye. With strings as the instrument, this is not strange. It is music theory. Notes overlap to make chords. Chords set the key. Within a key, distant notes still belong together. Entanglement is what happens when vibrations lock into harmony so that a change in one obliges the others to resolve. The cosmos stops being a field of isolated points and becomes a score. You and I are not outside of it. Our atoms share histories with ancient light. The air remembers thunder as pressure that once passed. Every warm object is a web of correlations with its neighbors. To be is to participate in a pattern. Time fits this pattern more gently than we expect. We count it in clocks and shadows and seasons, and it behaves well enough for trains and appointments. Yet even before strings enter the room, relativity makes time elastic. High speeds and heavy gravities stretch and squeeze its intervals until two observers can argue honestly about how much has passed. Add strings, and time begins to feel less like a rigid axis and more like a rhythm the instrument itself supplies. Vibrations do not merely make particles, they lay down pulse. What we call a moment could be the way many modes briefly align. What we call a flow could be the way those alignments change as the state reorganizes. This leads to a shy question. If the instrument were ever perfectly still, would time have meaning? A string in string theory is not a thing that then vibrates, it is its vibration. An electron is the event of a certain pattern being sustained. A photon is the event of another. If all patterns ceased, there would be nothing left to register before or after. The vacuum itself prevents such silence. Even empty space is busy with zero-point motion, the unavoidable baseline of the quantum. Pairs flicker into allowance and out again. Fields quiver too softly to light a room, but loudly enough to keep absolute stillness from existing. The quietest universe is still a hum. And yet the thought of silence is useful. It tells us that existence and vibration are not neighbors, they are synonyms. Remove the music, and the stage is gone with it. Early universe sketches sometimes speak of a near-perfect symmetry, a poised balance with no chosen direction and no distinguished parts. Then a selection happens, a tiny tilt in the instrument's configuration, and the first bars begin. The symmetry breaks. Modes that were equivalent choose different roles. Fields pick values. Interactions wake. Reality, in that telling, is the sound of silence breaking and learning to sustain itself. Black holes draw this logic toward places that feel nearly still. Near the horizon, time for a distant observer appears to slow, and signals struggle to climb out. Inside the classical picture, the story runs to a singular end, a place where description itself fails. A string-based view keeps more texture. It lets the horizon carry degrees of freedom that count like microstates. It lets infalling patterns be rewritten as correlations along the edge, so that information is transformed rather than erased. The interior may still be unreachable, but the score at the boundary can be read, and the reading hints that nothing truly silent waits inside only a different arrangement of the same instrument's notes. Far ahead, the picture cools. Stars exhaust their fuel. Galaxies dim. Matter may one day decay. The universe could tend toward a thin, cold state, where only the faintest excitations remain. Not silence. Exactly zero-point motion allows no such end, but a hush that stretches across a near-empty hall. Even there the beat persists, the bare minimum that the quantum allows, like the soft ring a bell, keeps after the last strike has faded. Return to the present, and the arrow of time finds a kinder story. We say it points from past to future, because entropy tends to rise. Cups shatter, heat spreads, order loosens. That rule holds beautifully for kitchens and stars, but it also seems to emerge from something deeper than counting scattered pieces. When many degrees of freedom begin uncorrelated and entanglement grows, local observers see entropy increase, because more of what matters about the whole is stored in relations they cannot access. The arrow, then, is not only disorder expanding, it is harmony thickening chords forming among parts that were once indifferent. Once formed, those chords are hard to unmake without undoing nearly everything at once, which is why the cup does not leap together from shards on the table. If extra dimensions exist, The rhythm may change its accent from place to place. In some folded shapes, the allowed vibrations could yield regions where what we call time moves gently. In others, it could loop, or fail to appear as a separate measure at all, replaced by a constraint that orders events without a universal tick. None of this violates the ordinary that holds us. It enlarges the set of ways a coherent world can keep itself consistent. It helps to trade metaphors with care. Think less of a river that carries us along, and more of a pulse that arises from the players themselves. The drum does not keep time separately from its sound. The rhythm is the sound. So with strings, as they resonate together, the world experiences duration. As patterns settle and disperse, we name the difference before and after. Where patterns are sparse and steady, time feels thin. Where they are busy and changing, time feels full. We are woven into that feeling. A thought, a memory, a heartbeat are each small alignments in a much larger meter. Entanglement returns once more, this time as the suspected scaffold of the stage. If geometry truly arises from quantum ties, then adding or removing entanglement is like adding or removing planks from a bridge. Cut enough links and distance grows. Lace more links and distance shrinks. A pair prepared together and then flung apart might still be connected by a thread the fabric recognizes even if we cannot pull on it. An accounting tunnel that guarantees the sums match. No message passes. Only consistency does. The strange part is how familiar this can feel. Once accepted, music works the same way. Intervals fix each other's places, even when played on different instruments in different rooms. Change one, and others must move to keep the harmony. From this vantage, the question, what if the strings stopped, is less about doom than definition. A stopped string is not a string. The way a turned-off lamp is not light. The universe keeps playing because play is what it is. The baseline hum, the lowest allowed energy, cannot be lowered away. Our task is humbler, to learn which overtones are present and how they interfere, to read the score written into the behaviors we can measure. Gravitational waves ferry the percussive notes of distant collisions. Spectral lines in starlight report on the fine structure of atomic chords. Tiny fluctuations in ancient background light sketch the very early tempo. None of these is the whole piece, but each is a clear bar, and together they teach the theme. What remains is to live inside the music with attention. The universe may be far more connected than it looks, with hidden bridges at the quantum scale and extra rooms folded into every point, but the same grace reaches our scale in quiet ways. Two clocks flown apart and reunited refuse to agree. A chilled superconductor carries current without loss. A pair of photons pretend to be one decision until we force them to choose. These are not party tricks. They are footprints of a deeper rhythm that strings make natural. We do not have to hear it with ears. We notice it in coherence, in symmetries that refuse to break, in calculations from very different roads that still rhyme at the answer. If the picture is right, the universe is not a warehouse of parts, but a conversation of patterns. Space is the grammar those patterns prefer. Time is the meter they keep. Matter and force are recurring phrases. Black holes are tight rhymes. Entanglement is the glue in the binding. Even the quiet you feel at night is not silence, but a well-tuned rest, a counted pause inside a score that continues beyond the window. To be here is to be a small resonance in that score, humming with the rest, carried forward by a melody older than stars and still learning new ways to be remembered. Imagine very far from now, a universe that has grown thin and quiet. The bright rush of star-forming clouds has faded, galaxies have drifted apart, and the sky has emptied into a dark so gentle it almost feels like a pause between breaths. In that distant age, the grand crescendos will be over. What remains may be little more than a single, endless, almost inaudible hum. And yet, even in that far-off quiet, there is something strangely comforting. Because if the strings at the heart of reality can never truly stop vibrating, then the universe never quite slips into silence. It keeps humming softly, invisibly, endlessly, like a lullaby stretched across forever. Maybe that faint hum is what keeps everything from falling back into nothing at all. In that sense, what we call silence might not be an ending. It might be a slower movement in the same long song, so deep and drawn out that we have no way to hear it yet. If the universe is a melody, then it is tempting to wonder whether it is the only one. Perhaps our universe is just a single line in an endless concert of realities, each with its own score, each built from its own shimmering web of vibrating strings. String theory makes room for that thought almost naturally. It does not offer just one possible cosmos and close the book. Its equations bloom with many solutions, like a staff that can hold far more notes than any one tune can use. When physicists first followed those equations into their deeper folds, they discovered something both unsettling and beautiful. There was not just one way for the hidden dimensions to curl, not just one pattern for the strings to trace. There were countless possibilities, each one a slightly different design for the tiny holes wrapped into every point of space. Change that design, and the allowed vibrations change too. Shift the allowed vibrations, and you change which particles exist, how strong the forces are, even whether stars and atoms can form. It began to look less like a single universe being described, and more like a whole orchestra of potential worlds, each playing its own variation on the cosmic theme. Some estimates suggest a number of possible universes so large that writing it down barely helps a 10 with hundreds of zeros, far more than the atoms in the part of reality we can see. In that picture, every consistent universe is like its own concert hall, complete with its own instruments, tunings, and rhythms. Some halls might host music not too different from ours, gravity a little stronger or weaker, or light traveling with a slightly different accent. Others would be so strange that our words would fail worlds without familiar matter, without galaxies, perhaps without time that feels like a line. And yet, if the mathematics is trustworthy, all of them would belong to the same grand composition. This raises a quiet, almost childlike question. Why are we here, listening to this particular song, rather than another? Why do the strings in our corner hum in a way that allows stars to burn steadily, planets to cool, chemistry to tangle itself into living things that can ask questions in the dark? One gentle answer is that in the vast hall of possibilities, we could only ever wake up where the music supports listeners. In most arrangements, the strings might tune themselves into universes that are beautiful on paper, but barren in practice. No atoms, no stable structures, no chance for long stories to be told. We find ourselves in one of the rare rooms where the notes stack just right, not because the room was chosen for us, but because only in such a room could anyone sit and notice the sound. This thought is sometimes called an anthropic perspective, but you do not need the name to feel its humility. Our universe is not necessarily the prize of the multiverse, only one seat in an almost boundless concert hall, and we happen to be sitting where the melody makes sense to beings like us. Humbling as that is, it does not make our song any less real. If anything, It adds a layer of tenderness. In a landscape where almost anything that can happen does happen somewhere, the fact that we are here at all sharing this particular stretch of music is quietly astonishing. There is also a deeper possibility that whispers underneath. If many universes are allowed, are they truly separate? Or could they be linked in ways too subtle for our usual senses? Some versions of the theory suggest that different cosmic rooms might not be perfectly sealed off. Instead, they could be like different resonant patterns on the same great instrument. The strings that define one universe might, under rare and violent conditions, brush against the strings that define another. If so, the multiverse would not be a loose collection of disconnected islands, but an interwoven structure, a vast concert where each hall is built into the same overarching architecture. In that case, it becomes natural to wonder whether the faintest echoes of other songs might seep into our own. A few physicists have speculated that certain oddities in the afterglow of the Big Bang, the thin, cold light that still bathes the sky, might one day be traced to a close pass with another universe long ago, like a muffled chord felt through a shared wall. So far, the evidence is fragile and uncertain, but the idea itself changes how the room feels. Even if those echoes are never confirmed, the possibility that our universe has neighbors turns our solitary story into part of a larger chorus. Thinking this way does not shrink our place, it enriches it. Our world is no longer the entire stage, but one performance in a much bigger show. And everything we know, every star, every atom, every quiet breath is part of a wider tapestry than we first imagined. Somewhere beyond the edge of what our telescopes can ever see, other halls may be ringing with their own beginnings and endings, their own arrows of time, their own versions of matter learning to listen. We may never hear those songs directly. Perhaps it is enough simply to know that the concert might be larger than we thought, and that our small melody is woven into something that does not need an end. At this point, the questions can feel so wide that they almost leave science behind and wander into philosophy. When you speak easily of 11 hidden dimensions, strings smaller than anything we could ever hope to probe, and entire universes beyond any practical reach, it is natural to ask whether this is still physics, or has become an intricate story told in equations. That tension has always been part of the journey. Physics begins with what can be weighed and timed and tested. It grows from experiments that can fail, from observations that resist our wishes. Yet every time we have followed that path far enough, we have arrived at ideas that were, at first, far beyond what the instruments of the day could check. There was a time when atoms themselves were pure speculation, and a time when curved space-time sounded like a philosopher's dream. When quantum mechanics was young, its talk of probabilities and superpositions felt less like a description of hardware and more like a riddle. Only later did these notions become the backbone of technologies so ordinary we barely notice them anymore. In that light, string theory may not be an ending where science dissolves into story, but the beginning of a new stretch of curiosity, one where the questions reach ahead of our tools for a while. Critics are right to demand more than beauty. A theory that cannot, even in principle, be tested risks drifting away from the world it seeks to explain. Calling something physics does not make it so. Nature does not bend to our preferences, yet usefulness wears many faces. Even without direct sightings of strings, the framework has already sharpened our understanding of black holes, suggested deep connections between gravity and quantum information, and provided new ways to think about the earliest moments after the Big Bang. Ideas born inside this theory have wandered out to help in other corners of science, like travelers leaving home with unexpected gifts. there is also the quieter service it performs. It teaches us to live with questions that do not fit neatly inside the old boxes. If reality is truly woven from vibrating strings, then there are layers of why that no experiment can easily touch. Why these particular vibrations and not others? Why this choice of hidden geometry? Why something rather than a restful, impossible nothing? These are questions that sound philosophical because they tug at the root rather than the branches. Perhaps it is natural that, at the frontier, physics and philosophy find themselves standing side by side, looking out into the same dark. None of this turns the theory into certainty. The universe will be what it is, whether our stories match it or not. But there is something deeply human about using mathematics as a lantern to see a little farther. For centuries, numbers and equations have been our best way of listening to the world. From the falling of apples to the arc of planets, from the spectrum of starlight to the jitter of electrons, patterns written in symbols have described reality with an accuracy that still feels uncanny. String theory leans hard into that success and makes a bold suggestion. Perhaps mathematics is not only our language for the universe, but the universe's language for itself. In this view, the tiny strings are not just physical filaments. They are expressions of underlying equations. Each allowed vibration is like a solution to a vast, intricate problem. Change the equation, and the solution changes. Change the solution, and the world it describes changes too. The particles we meet become equations, turned into motion. Forces become relationships, encoded in the way those motions influence one another. Even the shape of space-time becomes a reflection of the algebra that permits certain patterns and forbids others. Reality, at its quietest level, looks like mathematics in motion. And somehow, in the middle of all that abstraction, we find ourselves, not outside the calculation, but inside its temporary arrangements of strings and fields that have, for a while, learned to ask what they are made of. Our thoughts, our questions, our small private wonders are part of the same grand working that guides galaxies and holds atoms together. Whether or not string theory is the final description, it leaves behind a gentle, enduring image, a universe that is music you can write in equations, a reality that is both precise and tender, and a night sky that is not silent at all, but filled with a harmony so vast that we are only just beginning to sense its outlines. There is a quiet kind of question, hidden beneath all these strings and dimensions, one that sits very close to sleep. What does it really mean for mathematics to fit the universe so well? Is it a clever tool we invented to keep track of patterns? Or did we stumble onto something that was already there, waiting, like a melody in the dark? If it is only our invention, it is astonishing that it reaches so far, wrapping itself around planets, particles, and the age of the sky. If it is something we discovered, then perhaps the universe is not just described by mathematics at all. Perhaps, in some deep way, it is mathematics, a structure that exists because its own internal rules allow it. String theory leans gently toward that second thought. In its quietest language, the universe is not a lump of stuff that happens to obey equations written on top of it. The equations and the universe are the same story told in two voices. Matter, energy, space, and even time could be the visible faces of deeper, invisible relationships, pure patterns that happen to be capable of becoming stars, oceans, and the warmth of a human hand. When physicists follow the algebra, they don't find a single tidy solution and then stop. The same basic rules unfold into a whole landscape of possible worlds. Each one a different way the hidden dimensions can curl, a different way the strings can be tuned. Those extra dimensions are not added for drama. They are demanded quietly by the mathematics itself. Take them away, and the equations lose their balance. Keep them, and the story holds. Change the way those small, folded rooms are shaped, and everything else shifts with them. A tiny tweak in the score of the universe can give you a world where gravity is stronger or weaker, or where atoms never settle into familiar shells at all. A slight change in the allowed vibrations can erase chemistry as we know it, or spin up a very different version of it. The difference between something and almost nothing may be hidden in those subtle mathematical choices. One of the most unsettling and beautiful habits of mathematics is the way it gets ahead of us. Long before anyone had seen a black hole, the equations of general relativity were already whispering that such objects should exist. Quantum theory predicted whole families of particles before accelerators ever coaxed them into view. In the same way, string theory's formulas have led to ideas about gravity, entanglement, and the deep stitchwork of space-time that we have only begun to test. It is as if the symbols know the route before the instruments do, sketching parts of the map in faint lines that later experiments may darken. So when we say that mathematics might be composing reality, we are not only being poetic, we are entertaining the possibility that the universe itself is a kind of mathematical object, existing because such an object can exist. In that view, our cosmos is less like a machine built out of pieces and more like a theorem that happens to be true, or a piece of music that becomes inevitable once the opening notes are chosen. Given certain basic rules, there may only be a narrow family of ways for a self-consistent universe to unfold. We are living inside one of those ways, listening from the inside as the proof slowly writes itself. Of course, this replaces one set of questions with another. If reality is an equation in motion, why this equation and not some other? Why these particular vibrations, these constants, these hidden shapes? No one knows. Yet even without the answers, there is something quietly moving in the idea that beneath all the messiness of daily life, beneath accidents and improvisations and chance, there might be a kind of clear, crystalline order too deep to see directly, but steady enough to support everything that rests above it. Science, at heart, is the way we talk back to that order. It is a conversation between imagination and evidence, a slow dance between theory and experiment. One side writes bold, elegant possibilities. The other side checks, listens, and sometimes says no. When the two sides agree, even briefly, something new becomes solid enough to stand on. String theory lives near the furthest edge of that conversation. It is a framework made almost entirely of thought and symbol, waiting for our instruments to become sensitive enough to ask the right questions of the world. The difficulty is simple to say and hard to overcome. The strings, if they exist, are unimaginably small. To poke them directly, we would need energies far beyond anything our current colliders can dream of. So, physicists look for gentler clues, indirect fingerprints the theory might leave. One hope is hidden in gravity itself. If extra dimensions really do exist, then at very tiny distances gravity might behave just a little differently from what our current laws predict. Experiments have already tried to measure its pull at scales smaller than a human hair, searching for the faintest deviation. The measurements keep sharpening, like ears learning to hear softer and softer sounds. Another hope lies in the sky's oldest light, The early universe was a furnace so dense and bright that any string-based effects would have had their best chance to speak. As space expanded and cooled, that early fire left behind a thin afterglow, the cosmic microwave background that still surrounds us. Tiny temperature ripples in that light are like freeze frames of the universe when it was very young. In those ripples, some cosmologists hope to find hints of extra fields, extra dimensions, or unusual patterns of fluctuation that might be easier to explain with strings than without them. Gravitational waves and particle collisions add their own clues. When massive objects like black holes merge, they send shivers through space-time that our detectors can now feel. Subtle differences in how those waves fade could someday hint at new structure beneath Einstein's smooth geometry. Down on Earth, machines like the Large Hadron Collider smash particles together at immense energies. Some versions of string theory predict new particles or delicate shifts in familiar ones that might appear in such collisions. We have not seen clear signs yet, but each careful "no" trims away whole branches of possibility and nudges theorists toward models that fit more snugly against what the world actually does. The gap between what string theory talks about and what we can measure is wide, but history is kind to such gaps. Ideas often appear long before the tools to test them. Atoms were once pure speculation. Curved space-time was once an audacious guess. In that sense, string theory may be another early arrival, waiting for technologies we do not yet know how to build, or for clever new ways of reading data we already have. Even in the meantime, the mathematics has not been idle. Techniques first developed for strings have helped physicists study black holes in more detail, revealing that their entropy and temperature can sometimes be understood by counting hidden microstates in a stringy language. The same tools have wandered into other fields, illuminating strange phases of matter, sharpening our grasp of entanglement, and giving new ways to think about how information moves. The strings, even unseen, have reached their vibrations into many corners of our understanding. If the theory is right, then all of this brings us back to something quietly intimate. You are not just living in a universe made of strings, you are made of them. Every atom in your body, every particle that carries your thoughts, every cell that takes in air and light, is built from patterns that, in this story, are nothing but particular ways of vibrating. Life is not separate from the cosmic music. It is one of its melodies. Seen that way, the old feeling of standing apart from the cosmos begins to soften. There is no clear line between out there and in here. The same laws that shape supernovas also govern the chemistry of a single neuron. The same constants that decide how galaxies form also decide how your lungs trade oxygen for carbon dioxide. You are not sitting outside the song, listening. You are a chord inside it, a temporary, intricate harmony born from strings that have been humming since long before you were here. Biology, under this light, is just physics, arranged in especially delicate patterns. A heartbeat is a rhythm nested inside a deeper rhythm. The glow of a thought is an electrical flutter riding on quantum rules that pay no attention to borders between minds and stars. Other universes, if they exist, might host other kinds of life, or none at all forms so alien we would not recognize them, or quiet rooms where the music never finds a way to braid itself into listeners. But here, in this particular tuning, the vibrations have allowed something to lift its head and wonder what it is. It is tempting to ask what role, if any, we play in all this. Are we only witnesses, small pockets of awareness, watching the universe carry on without us? Or is our very act of wondering part of the performance, another resonance, another way the cosmos expresses the patterns it has chosen to sustain? Some people have suggested that consciousness itself might be a kind of emergent vibration, a high-level echo of the same mathematics that gives rise to particles and fields. That is speculative, and it should be held gently. Still, there is comfort in the thought that your awareness is not an intrusion in a silent universe, but a subtle feature of a universe that was never silent at all. If strings really do underlie everything, then life may not be an accident tacked onto a cold, indifferent world. It might be one of the natural things a vibrating universe does when given enough time and the right conditions, no more unnatural than a galaxy, no more out of place than a star. In that view, the cosmos has always carried the possibility of listeners within it, the way a melody carries the possibility of harmony even before anyone sings along. You do not need to solve the equations to belong to that music. You are already woven into it, as surely as your heartbeat is woven into your night. Long before you were born, the strings that now make you were humming in other arrangements. Long after you are gone, their vibrations will continue in forms you will never see. For this brief span, they have taken the shape of your body, your memories, your quiet questions before sleep. That, too, is part of the story string theory is trying to tell. That the universe is not only made of vibration, but that you are one of the ways it has learned to hear itself. And maybe the most quietly astonishing thing in all of this is that, somehow, we can listen to it at all. Consciousness is the soft mystery sitting at the center of everything you experience. Every color you see, every memory that drifts through your mind, every feeling that rises and fades, all of it happens inside this simple, impossible fact that there is a you here to notice it. We can follow signals through the brain, trace how neurons flash and talk to one another, map regions that wake when you speak or dream or remember. But none of that quite answers the gentler question. Why does any of it feel like something from the inside? Why does the universe, after billions of years of blind vibration, suddenly find itself looking back through your eyes and wondering what it is? Set that question in a universe made of strings, and the wonder only deepens. If every particle in your body, every atom in your brain, is just a particular way a tiny strand of energy is vibrating, then your awareness cannot float above the music. It has to arise from it. In that picture, consciousness is not a separate light switched on at the end. It may be a resonance, an unimaginably intricate pattern formed by countless strings, humming together in just the right way across the matter that has slowly learned to call itself me. Even at the level we can measure, there are hints of this rhythm. When you rest, when you concentrate, when you fall towards sleep, the electrical activity in your brain gathers into waves. Thoughts seem to come with certain patterns of oscillation. Emotion and attention leave their own faint pulses. Underneath the chemistry and the biology, string theory suggests there is an even deeper layer of trembling structure, too fine for any electrode to touch, an underlying hum that every cell, every molecule, quietly inherits. It is hard not to wonder, what if consciousness is what it feels like from the inside? When the universe's vibrations become aware of themselves, there is a gentle elegance to that idea. If everything that exists is part of a vast, silent symphony of strings, then we are not outside the music listening in. We are built from the same notes. The melody does not just surround us, it plays through us. Perhaps awareness is simply a particular kind of harmony. The cosmos can form a delicate, temporary alignment in which the song pauses just long enough to hear its own echo. That might also be why consciousness is so slippery whenever we try to pin it down. If it really is an emergent pattern rather than a single object, you would never find it in one neuron, one region, one exact spot. It would be spread out like a cord across many strings, many cells, many levels at once. Change the pattern too much, and the cord dissolves. Keep it balanced, and it holds, long enough to carry a life. And if awareness is tied to deep patterns of vibration, rather than to one specific kind of matter, then it may not be ours alone. In a universe where everything is built from the same trembling threads, who can say how many ways there are for those threads to arrange themselves into something that feels like a mind from the inside? Perhaps there are forms of consciousness that move too slowly or too quickly for us to recognize. Lives played out in different media, under different laws, in different folds of the larger fabric. Patterns of awareness that never touch carbon or water, but still rise from the same fundamental music. We do not know. For now, these are soft questions we can only hold, not answer. But they flow naturally from the idea of a universe whose first and last language is vibration. What we can say is simpler. In such a universe, we are not apart from the song. We are the part that can hear. Maybe that is why, in rare quiet moments, when the room is still and the world seems to fall slightly out of focus, there is sometimes a sense of something just beyond words, a subtle hum beneath the thoughts, a feeling that you are not simply inside the universe, but made of the same thing it is made of. Maybe that is nothing more than neurons settling into a calmer rhythm. Maybe it is just a tired brain trying to make peace with itself. Or maybe, in those small pauses, you are feeling a faint echo of the same deep vibration that has been running since the first strings began to move. Whether consciousness is entirely biological or partly woven into the fabric of reality itself, the story that string theory offers is a gentle one. It invites you to stop treating awareness as an accident perched on the edge of an indifferent cosmos. Instead, it suggests that awareness is another mode of vibration, another way the universe has found to exist. Not an interruption of the song, but one of its quieter themes. And if everything is music at the deepest level, then our role here may be simpler and more sacred than we think. To listen, to feel our small piece of the pattern, and, in feeling it, to let the cosmos know itself just a little more clearly. From the tiniest scales upward, you are a stack of vibrations. Quarks gather to form protons and neutrons. Electrons occupy their ghost-like orbits. Atoms link into the molecules that build your cells. Cells knit into tissues, tissues into organs, organs into a body that breathes and moves and remembers. Layer upon layer, pattern upon pattern, until something appears that can say I am, and wonder what that means. In that sense, you are a living chord, a cluster of notes, struck from the same strings that weave suns and nebulae together. The difference is not that you vibrate and other things do not. It is that your particular cluster of vibrations has become complex enough to notice the rest. A rock does not stay awake at night, asking why existence is possible. A tree does not try to picture 11 dimensions. You do. Perhaps that is your small, fragile gift to the universe, to give its music an ear, to take the silent hum of reality and turn it into meaning, questions, stories, and the quiet comfort of knowing you are not alone inside it. So what, then, are we? Maybe we are notes that know they are notes, patterns of vibration that have become capable of turning around and asking after their own origin. The universe does not need us to be vast, to be meaningful. It only needs us to be attentive. Brief as we are, our awareness is still a way for the song to become aware of itself. There is, at the heart of all music, a stillness that holds it together. Without pauses, without the tiny gaps between one sound and the next, everything would blur into noise. It is the space between notes that lets a melody breathe. The same may be true of reality. If strings are always in motion, their motion still unfolds against a background of something calmly enduring. Vibration needs a backdrop of quiet in order to be noticed at all. We spend most of our days caught in the loud parts of existence, the rush of tasks, the pull of worry, the constant chatter of thoughts. The universe feels busy, crowded, full of motion. But beneath all of that movement, there is a softer layer, a kind of deep, steady silence that makes room for the rest. String theory does not only describe a world of ceaseless trembling, it hints at the stillness inside that trembling, the quiet that gives shape to the dance. That quiet is not empty. It is the possibility of everything. It is the open space in which vibrations can arise and fade. You can feel small pieces of it in your own life, in the breath before you answer a difficult question, in the few seconds between hearing your name and deciding how to respond, in the wordless pause before sleep finally takes you. Those are the tiny human versions of a more ancient stillness, stretching between galaxies, separating stars, making room for each new pattern the universe will try. If reality is indeed music, then we are not only made of its notes, we are held by its quiet too. So tonight, if you happen to close your eyes and let the noise fall away for a while, you might imagine the strings beneath everything humming in dimensions you will never see, weaving the space around you, vibrating in every atom of your body. You might imagine their song not as sound, but as presence, a gentle persistence that fills every corner of reality, whether you notice it or not. And somewhere inside that vast, unseen orchestra is the particular, fragile melody that is you. Rest there for a moment, in the space between thoughts, where the world grows softer and edges blur. That space is part of the universe as surely as any star. It is where the music gathers itself before beginning again. Small as we are, we live in that place, two between notes, between questions and answers, between one heartbeat and the next. The song has been playing since long before there were ears to hear it, and it will go on long after our short phrases have faded. Our task is not to solve it or name every note. Our task, maybe, is simply to listen as kindly as we can, to let its rhythm soften us, and to remember, when we feel lost or separate or small, that we were never really outside the music at all. If these thoughts have kept you company tonight, if you felt even a hint of that deep hum beneath everything, you are always welcome to return to this quiet. And if you'd like to wander through more questions like these, you can leave a gentle like, subscribe, or simply find your way back when you need a soft place to rest. The music will still be playing either way. For now, let the questions loosen, let your body grow heavy, and let the universe's soft, patient rhythm carry you. You have always been part of the song. Good night.